Okay, I was worried about running out of space, so I didn't write out the entire equation. I just wrote out the key details so that I'd know what I was working on. But starting with number 1, we're given the information that f of 2 equals 5 when the nth is odd. I tried to draw the nth normal, but it's probably going to confuse me as I go through this. I should have just drawn it as a normal n. And n is greater than or equal to 1. The nth derivative of f at x equals 2 is given by that when n is even, the nth term at x equals 2 is 0. Okay, so starting for the first one, asks for a Taylor series for this, for f about x equals 2. I wrote down the equation for it so that I could just plug in my stuff about x equals 2. Only worried about odd numbers. I wrote talking points because I knew that I'd struggle to get through all of this. And then we got to f of x equals the series sum and equals 0 to infinity of f to the 2n plus 1 times 2, f to the 2n plus 1 times 2, because 2 is my a, because it's where it's centered, over 2n plus 1 factorial times x minus 2 to the 2n plus 1. There's a lot. Then you substitute what we got, or what we were given for f of n, which is n plus 1 factorial over 2n, into it. So as you can see, I literally just plugged it into it, multiplied it out, and then you simplify, getting rid of a lot of like terms, getting rid of your factorials, to end up on 2n plus 2 times x minus 2 to the 2n plus 1 over 2 to the 2n plus 1. And then that is your final series. But I forgot to write the 5 plus because we were given the information that f of 2 equals 5 at the top. So it would, at 2, it would start with 5. So it'd be f of x equals 5 plus the series. So that's why I put a little one right here. But maybe I'll draw an arrow just so there's no confusion. Hope I'm right about that. B. I asked the integration interval, blah, blah, blah. So the easiest way to do that is to do the ratio test, where you have your n plus 1 term over your n term. Easier way than just dividing and making a 4-stack sandwich is to multiply by the inverse. That's why I wrote a note here saying inverse. I was telling myself to talk about it. So the limit as n approaches infinity of these two terms multiplied together equals 1 over r, which equals the limit as n approaches infinity of those terms multiplied together. This is it simplified. I didn't want to write out all the work. And then that equals 1. And then r equals 1 because you divide, or you multiply the r on this side to get 1 equals r. R equals 1. Yay. And then for your interval, you take your a, which is 2, minus r, which is 1, to get 1, and then you take your a plus your r to get 3. So the interval of integration for this series is 1, 2, 3. Number 2, we got f of x equals the series